Greetings one and all, and today we are going to discuss about the addition of vectors by rectangular components. As we are having three major components x, y, z axis which are mutually perpendicular. If an angle is formed on x axis, that's alpha. If an angle is formed between x and y, then it is known as alpha angle. If the angle is formed between y and z, it is known as beta. If an angle is formed between x and z, it is known as gamma. These are some points out of which, first suppose these are we are having this Cartesian coordinate system in which there is a vector. There's a vector, position vector, which is going straight, and that vector is named as a. That is a1. I'm unable to write properly here over the screen. This is a1. Now I want to add another vector with a1, which is known as a2. Now, in order to add a1 with a2, I will be uh, adding vector a2 over its head. But before that, in order to calculate a1, this vector a1 is should be undergone a resolution, which means we would be resoluting vector a1 into its components. What kind of components? So first of all, uh, this is vector a1 which is drawn alongside a line which is known as OB, and after that there is another vector. Now, in order to resolute into its component, this vector will come downside. This vector will be resolved into its component. What kind of components this would be? This would be a1x, a1x, and that would be a1y, a1x and a1y, a1x and a1y, which would be drawn over here. So this is a1y, this is a1x. Now, I want to draw, I want to add vector a1 with vector a2. For suppose I'm drawing another vector over here. So suppose this is vector a2. This is a2, and this vector is having its line as C. Now, how can I describe this diagram? This diagram will be described in such a manner that two vectors a1 and a2 having magnitude a1 and a2, which are represented by the lines OB and OC, making an angle theta 1 and theta 2, making an angle theta 1 and theta 2 along the x-axis, is the description for this diagram. That's two vectors a1 and a2 which are making an angle, which are represented, two vectors a1 and a2 having magnitude a1 and a2. Let me just describe it. Sorry for the interference here. Two vectors a1 and a2 having magnitude a1 and a2, which are represented by a line OB and OC respectively, making an angle theta 1 and theta 2 along the x-axis. Along the x-axis. Sorry for this. This is theta 1. This is theta 2. Theta 1 and theta 2. These are making an angle theta 1 and theta 2 along the x-axis. Two vectors A and B, uh, which are having magnitude A and B, which are represented by line OB and OC having theta 1, having their angle theta 1 and theta 2 along the x-axis. So here there is, oops, let me just write it over here. Two vectors a1 and a2 having magnitude a1 and a2, represented by lines a1 and a2, represented by lines OB and OC, making an angle theta 1, making an angle theta 1 and theta 2 alongside the x-axis. Alongside the x-axis. So what can we define it? How can we define it? We can define it by the following explanation, that two vectors a1 and a2 which are having magnitude a1 and a2, which are represented by lines OB and OC, making an angle theta 1 and theta 2 alongside the x-axis. So this is how we are going to describe this line. What I want to do here is that I want to add both of these vectors. Vector a1 is having this these magnitudes a1y a1x. Vector a2 is having its magnitude as uh, oops, let me just erase it a bit and redraw it. Yeah, so here this is vector a1, this is vector a2, and it is having it is being represented by line OC, making an angle theta 2 along the x-axis. Apart from which, this a2 is in order to resolute it, I will be dividing it into two components. Component 1, a2y, a2y. What I can say is that this is component a2y, this is component a2x, component a2y and a2x. And in actual, let me just erase it and oops. These were the two vectors which I previously drawn over the screen, but here uh, there were two vectors, vectors A, vector B. This is vector A, this is vector A1, this is vector A2. These were the two vectors which I draw with theta 1, theta 2 alongside the x-axis represented by OB and OC having magnitude A1, A2. So now I want to add both of them. In order to add them, I will be utilizing head to tail rule. This is vector A1, and in order to add vector a1 to a2, I will be placing the tail of vector a2 on the head of vector a1, due to which when the tail of vector a2 will coincide with the head of vector a1, it will be formed in such a structure. Oops, it's a bit long, but you can understand it. This is a1, this is a2, a1x, this is a1y. Apart from which, there is the second vector a2, apart from which this vector will be also resoluted into its vectors, which is a2y and a2x. Now what does this represent over here? Now this represents the resolution of both of the vectors a1 and a2, but in order to add them, we have drawn a1, we have coincided the tail of a2 to a1, but we also need to draw the resultant vector in order to aid them in actual. So resultant vector will always be in the direction of head of last vector. So this is the resultant vector direction in the head of last vector, due to which this will be considered to be a resultant vector, and this resultant vector is considered to be force oppose A. Alright, and now uh, in mathematical form we can write it as A1 mathematical form we can write it as AX is equals to A1x plus A2x. AY is equals to A1y plus A2y plus A plus A2y. A1y plus A2y, and This is the value of ax and ay, that ax is equals to a1x plus a2x, ay is equals to a1y plus a2y. And this is how we actually find a total value of a. Now a is basically forming a complete triangle. It is forming a complete right angle triangle in which there are two components ay and ax. Ay is equals to a1y plus a2y, ax is equals to a1x plus a2x. Now in order to find the magnitude of A, what is the correct formula for finding the magnitude of A? Magnitude of A can be found by the formula A is equals to uh, A is equals to radical A is equals to A is equals to radical ax square plus ay square. That is a formula which we have previously derived as well, which is for the composition of vectors as well as for finding the magnitude of vector. So in order to find the value of a, magnitude of a, we are going to write the formula again, and that will ultimately become, now in order to find the value of ax, we are going to put the value of ax inside the formula. So it will become a1x plus a2x whole square plus a1y plus a2y whole square. Now as we know that ax is equals to a cos theta and ay is equals to a sin theta, we are going to put their values. So accordingly the equation will become a cos, I'm unable to write theta here as there is no symbol available, and that will also become a cos theta, which means a1x is equals to a cos theta 1 and a2x is equals to a cos theta 2. Secondly, we are having a1y, so it will become a1y is equals to a sin theta 1, a2y is equals to a sin theta, let me just write it, a cos theta 1, a cos theta 2. Now in order to simplify them, we are going to write further simplified in such a manner that here a cos theta 1 will be, as this is having complete square, we are going to square it, so it will become a cos theta 1 wholes a square cos theta 1, a square cos theta 1, a square cos theta 2. Instead of writing square over here, we are going to eradicate it, and here a square sin theta 1, a square sin theta 2 will be the final product in order to find the value of the magnitude of vector A. And accordingly we can also find the direction. The direction can be found in such a manner that theta is equals to tan inverse fy upon fx. Value of fy ay is equals to a1y plus a2y, and value of afx ax is equals to a1x plus a2x. Putting the value of a1x and a2x, we have our answer is a cos theta 1 plus a2 cos plus a cos theta 1 plus a cos theta 2 second upon a sin theta 1 plus a sin theta 2. So we can write it in such a manner that tan inverse a cos theta 1 upon a cos theta a cos theta 1 plus a cos theta 2 upon a sin theta 1 plus a sin theta 2. This is the formula for finding the direction, angle, and I'm hopeful that it's that's helped you today. hopefully we'll meet